Hello, we're here to talk about containerizing Kubernetes with containerizing Couchbase with Swarm and Kubernetes. And by way of introduction, I'm Eric Cooper. I manage a test automation team here at Couchbase. Do the test frameworks, infrastructure, as well as writing test cases.
And I am Tommie McAfee, senior engineer. Oh, my picture is pixelated, so I'm here. Senior engineer in test automation, so do a lot of test development and working a lot on our test framework, test implementation, and so I'll be sharing a lot about how we use Docker in order to build our test framework and scale it up with Swarm for system testing.
So we'll be talking about containers, frameworks, just discussing those in general, give an overview of our functional and system testing at Couchbase, and then we'll talk about how we kind of pulled them two together, how we got the containerization, the testing, working in an efficient manner. Goes without saying, containers are very popular these days. Definitely at least one step better than VMs. I like to think of them as being lightweight VMs. They have a number of good properties. They allow images to be created with just what you want on it, the flavor of the OS you want. In our case, we get pick up any Couchbase server, development build or otherwise, package it on a container and pull in the libraries, and we have something that's easily replicable. In terms of development environment, transition from QA, they're flexible in that as we find issues and want to reproduce an issue and pass it to the development team, it's just a matter of passing the container on. When we do our testing, we run one test with a cluster of Couchbase servers, and we really want the clean slate for the next test. So containers are really good that way. Run the test, the Couchbase server cluster on the container. It can be in a funky state at the end of the test, but that's okay. We just delete the container if needed, and next set of tests come up on a clean container. Whereas with VMs, we were finding that one test ran, left a Couchbase server on a VM in a bad state, and it would affect the other tests. And popular, according to Docker Hub, as of a few days ago, there's been more than 500,000 pulls for the various Couchbase products. Orchestrations are really a layer on top of containers, a special value add to make them that much more useful. In terms of aggregation, if there's an app that requires multiple programs, these can all be packaged in one thing as a service. This is an example for Couchbase. If we have a test which has a test client and a 3-node cluster, these can all be aggregated. And Kubernetes terminology for this is a pod. In terms of scaling, that's one of the big wins for the frameworks. It's possible to scale up the number of containers and scale across hardware all fairly transparently. And robustness, when a container dies, the framework, if a container dies, then the framework will automatically restart it, again transparently. And services, the framework will provide a descriptor or an endpoint where an application can find a service, and as the service, if the container is running underneath it, they can be restarted or moved to a different host. That's all transparent to the application. So a brief overview of our functional testing environment at Couchbase. And this really, the title says Docker, but it's prior to us using Docker. We have multiple test suites per component, component mapping to traditional Couchbase server functionality that you may or may not be familiar with. And each component will have more than one test suite. Test suites contains a number of test cases and a specific cluster configuration. In the simplest case, it'll be like a one-node cluster, and something like XDR will have a couple of four-node clusters. So the test environment really depends on the component and the test case. And lots of test suites, and our goal is, in terms of continuous integration, to run all the test suites every 12 hours so we can isolate bugs as the code is checked in. If a new bug is exposed, we can isolate where it was introduced. This is kind of the historical dating back earlier days at Couchbase. We used to have one Jenkins job per test suite, and it would couple the actual test suite, a configuration file of the cluster, and the VMs. And these are all coupled together in one Jenkins job, which could be run for a specific Couchbase server version. Just a few notes on the framework. We have the framework is written in Python and communicates via REST, CLI, Memcache protocol to the cluster and verifies results, be it something like rebalance complete or data keys all populated. There were challenges with this in terms of scaling. It was a solution that worked for, say, 5 or 10 Jenkins jobs, but as we got up more than 100, there were issues with it. One was just the number of Jenkins jobs. It was hard to manage that many Jenkins jobs. Another issue was useful information about test suite and cluster configuration. Kind of scattered about. It was connected in the Jenkins jobs, and very hard to kind of centralize this information. And the VMs themselves were, we used fixed IP addresses, so if a VM went bad, then we'd have to go through all the Jenkins jobs that use those VMs and replace the IPs. And the VM was a given OS, and if we wanted to run the same set of test cases against a different OS, then we would be duplicating the Jenkins jobs and replacing with the IP of a different VM. So as we move to Docker, just to highlight some of the key points on this slide, the test suite descriptors couples together the test suites and the cluster configuration together, and these are all stored in a Couchbase. And the test suite dispatcher will query the test suite descriptors to find the set of tests which should be run, and it is responsible for finding the available resources to run them on Docker. And the circle with the test suites, that's really Sequoia, which is what Tommie will be talking about, which pulls together a test client and the desired number of Couchbase servers to run the test with. And there's a function within the test suite dispatcher that's aware of the amount of hardware resources, and it will launch new test suites as it sees that resources are available. And what we found to date is with one physical server, 24 core physical server, that it can run about the equivalent of about 20 Couchbase servers and associated test clients kind of grouped into those test client Couchbase server combinations. And here's a screenshot of the Jenkins test executor. And one thing to note is instead of having a dedicated Jenkins job per function, this is kind of a generic Jenkins job. It takes as input the test suite, the cluster configuration, and it'll run that test. And in this example, where it's a screenshot of some running some XDCR test suites. And the move to Kubernetes is a work in progress. It's not a perfect match in that for the test suites, we want to have a start and a finish. The container launches, it ends, and that's slightly different than what I see as the Kubernetes model is, where a container will try to run as long as possible. Though there is something, a concept of jobs, which may be a solution for that. Another piece of this is the service definition, that the different test suites have different configurations. So I'm thinking that we would define services based on common configurations, like a 1-node cluster, a 2-node cluster, and then feed the test suites to those. So that's my piece, and Tommie will be talking about interfacing with Docker.
Cool. So given some of the things that Eric shared about how we're using the framework to use containers, to start containers, stop containers, the main thing is how do you interface with Docker, specifically the Docker engine, and we wanted to create just a generic way for doing that, for interfacing. And so theoretically, there's many ways you could do it. You could use the Couchbase or the Docker CLI. You could do it directly through the REST API, or you could use like an SDK or some third-party tool. So we decided to use the Golang SDK. So I'll get into like the decisions that went along formulating that test layer that we use in functional testing and in system testing. So just from a high-level perspective, there's basic building blocks for building our tests, especially from system testing, just data loading. We need a way to do querying. We need a way to do topology changes. So, I mean, the type of documents that we use from JSON, binary, creating them for querying, indexes. We need to create indexes, also delete them. And then topology changes, so moving things around in the cluster. So those are just some basic things. So from the outset, when it comes to just building a test framework, we've had enough tools created within the Couchbase ecosystem to say, well, that's not a problem. We can just pool all of the components together, like Pillowfight for data loading and CBQ for querying, and use Couchbase CLI for topology changes. So it would seem as if we could just take everything together. It's not a problem. Just package all the tools together and spit out a framework and just start testing with all of the requirements. But the issue becomes very complicated right away when you start to realize that all of the things that we have implemented already are written in different languages, right? So data loading, things like that, written in Go, and topology changes in Python. And even if you were like in the SDK talk earlier, we just like, there's just different development preferences. So we have really cool tools that do hit different parts of our requirements, but they're written in different languages. So the way you could approach this is maybe you could create some sort of bridge in between all the components, or possibly use some OS calls to start processes, or maybe just rewrite each of the components into a single language. But the good news with Docker News is that, hey, we can just containerize everything, and then that gives us a uniform interface in order to connect with all of the different types of tools that are used to meet data loading, querying, and topology changes. So the only thing we want to do was say, let's not implement data loading and all these things. Let's just interface the things that we already have and containerize it. So if you were to just take this perspective and as I talked about, there's ways to interface with Docker engine. So if you use the Docker CLI before, you could say, hey, let's build a test that just creates data and then creates an index and then does a rebalance. So we could say a pillow fight container written in C, point it to a Couchbase node, then do CVQ to create an index written in Go, and then do a rebalance with Couchbase CLI written in Python. So you already start to build like really simple testing with that. And then start to hit new requirements where, let's say I want to test it against a different cluster. Well, I don't know, maybe I could just change my IP address, but obviously that doesn't really scale at some point. So what we did was we started to build scope abstractions, which is essentially a way to identify IP addresses with things that make sense within Couchbase. This isn't like a host name DNS type thing. It's essentially a way to say, well, Couchbase has an idea of orchestrators, right? With the first node that you would add to a cluster, or data nodes or query nodes. So we wanted to have a way of identifying things in a generic way so that you could always run the same command in different places and do that abstraction. So just extrapolating from that idea, if you wanted to say, okay, well, I want to do the same thing against 100 VMs and I want to do data loading on the 70th data node. So, okay, let's say we have VMs and we all know the IP addresses of them. So I guess an approach could be you could create some sort of static file and create identifiers where you map the IP addresses to each of the 100 VMs. And maybe you could get by with that if your IP addresses never change and they're all static and you just want to test that cluster. But let's say we want to test against containers, which are Couchbase containers, which are just more flexible for starting. So at that point, we don't really know what the IP addresses are going to be of the containers at runtime, right? When we start them up beforehand. So we kind of lose that option of flexibility to do that. So the third piece that we put in there was a provider, which essentially what that does is it says, I will go and start however many Couchbase containers that you want, and then I'll predefine all these identifiers that are used within the scope that makes sense, right? So this thing starts containers and it just spits out the IP addresses to the scope, whatever the data node is, orchestrator. So at this point, the only thing that you would need to do to run like massively scalable tests is to point it to a Docker engine and say, that's my provider, and run these tests. So that sort of gives us some building blocks to say, okay, we have something of a framework going on here where we have some basic features like container pluggability. We don't necessarily need to write a lot of code. What is involved is plugging in different containers or Docker images, right? So we can pull anything from Docker Hub and inject it into our scope. So scope portability, which means you can run it anywhere. As I was pointing out before, you don't necessarily have to have the IP addresses aren't embedded in the test anywhere. And also just the scalability, right? So I want to run a test on my laptop, 4 nodes, 4 containers, and then I want to move it to the lab. So that's looking pretty cool. Just to start testing, again, this is interfacing with the CLI. What we did when we wanted to build just a simple framework to implement the same exact idea is just YAMLify the concept of starting containers, right? So this is a very simple test here of a YAML file, which each is sequentially what you see is the same images from Docker Hub. These are images that we built in-house, but they could be absolutely any image. And the reason why this is nice is because this also allows us to do the scope injection for each of the sequences here. So you can see the orchestrator at runtime would be replaced with whatever IP address is coming from the scope. And then we can add nodes. We could do it in a very intuitive way where we just want to add any node that's inactive without having to know anything about the cluster really. And yeah, just do a rebalance. So there's some other neat things you can do with that where say we want to scale it up. So there's other identifiers where there's a scale one that we can apply So let's say scale is 5. At this point, at runtime, the pillow fight image will run and your batch would be 500, right, if scale was 5. There's also a concurrency flag too, so same thing here, if the scale is 5, at this point you would get 5 instances of pillow fight running. So that's pretty cool, just being able to do that. But again, I want to actually, let me go to here. The image of what's happening here is we have a pillow fight container and it's running against Couchbase containers. So you could imagine a situation where you have a single VM, Docker VM, and you start 10 clients and you start loading data to 10 servers and they're all on the same VM. At some point, you're just going to reach scalability problems, right? So just moving into being able to really run large system tests, which is what we do in system testing, we want to move into Swarm. So, hey, development track. So we have some Golang interface here. Essentially, the provider piece that I talked about earlier is just an interface that says, hey, anything that implements this just needs to be able to spit out Couchbase servers. We have the Docker provider. There's other ones like File if you literally just wanted to do IP addresses. And then just added a new one for Swarm provider, right? And so the way that works underneath is it's exposing services, which is the way that Swarm sort of speaks as far as like containers. And what is happening essentially is containers are running inside of the service itself. So if you guys are familiar with Swarm, the general spread strategy is to evenly distribute the number of containers across physical nodes, right? So if I say I have a Swarm cluster and I have 4 machines, then if I want to start 6, 12 containers, then it's just going to evenly distribute it across those machines. And that is pretty nice if you want if everything runs the same amount of workload. But with testing, we often get into the situation where the client is really pushing data pretty hard, and it can affect the performance of the Couchbase containers, right? Or even vice versa, you could have something where a Couchbase container is really under a lot of stress and it affects your data loading. So what we started to do was add constraints with Swarm, and that starts to make the picture a little bit better, because then you could say, I want all of my clients to run on this on machine manager 4, and then put Couchbase servers on the other 3. And so it's basically that simple command that you see there at the bottom of running add a label. So we added labels, just call them zones, and for a client. And that at that point, when we start our containers against that zone, then they'll only start on that machine. And so that's starting to look a little better, but noticing as the test is running, the way Couchbase works specifically, there's even different services within Couchbase itself. So you have data services, you have index services, and then you can easily get into a situation where your index Couchbase server is basically monopolizing CPU on the data from the other data Couchbase servers. So an additional optimization here is to essentially do the same thing, but apply it to adding additional zones that map exactly to Couchbase services. So you start to get a little bit of a better picture, and it becomes very clear what you would want to start doing at this point, where you want to say, okay, this looks nice. My data manager, it looks to be getting pretty populated. So at that point, you could simply add a couple more data managers to sort of spread this out. And so, and I'll actually show like how this looks in when you're running, and the performance benefits from being able to do something like that. So Yeah, so I mean, basically the big wins from doing that is having the ability to automatically have the node distribution, then the labeling based on the services, and that's something that we sort of built in to be able to do that based on the type of machines that we want to start or the type of workflow that you have. And this is all for free because we don't have to rewrite any of our tests, right? We could simply say, point it to a Swarm provider, and at that point, we're able to take advantage of whatever the hardware is presenting us. So at this phase, we're going to move into a couple demos. So Eric's going to share the practical steps of how he uses Kubernetes, and then I'll come back and share the use case that I just spoke about with Swarm.
So I put together a little demo with Kubernetes on really for demonstration purposes, running on a VM. You know, so Kubernetes generally is multiple hosts, a master, and something called minions. I have just done a single node demo here. Typical or almost all Kubernetes commands start with the kubectl, and I'm just going to get the nodes. So we have one node up for 40 days, and I'm going to create a service. And just to take a look at the YAML file for it. It consists of a replication controller. This is the one that makes sure the right number of pods are running at a given time, and the service descriptor. Key things to note is the image, which has a Couchbase image, and just exposing the service as a load balancer. So I'm going to create the service. So we can see the service has been created, and we'll take a look at the replication controller. And this shows that we have one instance of the container Couchbase server, and we'll also do get pods, and we have the one instance here. So now I'm going to scale up to assuming there's more load or we want more Couchbase servers. There's a simple command to scale up. We're going to go up to 3 replicas, and this is going to be get. And then we can see the 3 instances of the Couchbase server running there with distinct containers. And lastly, we'll just look at the endpoints of the servers. See, networking, as I think is well known, is a little tricky with containers, but we can see the 3 endpoints, and if we take a look and see what's there, it has moved, but and if we see, this is the UI of the Couchbase server, and if I was better with port forwarding and the like, that would be visible in a browser, but I think we can see that it is a Couchbase server running in there.
Sweet, thanks. Okay, so on the Swarm side of things, I have here, I have 8 nodes. This is not looking good because this is unreachable. Maybe we will do something off. Okay. Let's see. We'll just have to see what happens with this but I'm going to try and see if I can get rid of this. Okay, hopefully. Okay, and I configured the, okay, so we're gonna do some ad hoc stuff here. All right, so I have a couple zones here for now 7 Swarm nodes. If you notice, I have data index client, so I actually need to add, what I'm going to do is actually remove the label on this data node here. And I'm doing this because, remove label for the zone key. And I'm going to add it back as a query label. This was completely oops, it's commented out. All right. Okay, so just from a Swarm perspective, we have these nodes. So the test I'm going to run, from what I talked about before, from the scope and the test, essentially what you have is, I've defined here 15 Couchbase servers to start. And I said I want to have 2 query nodes and 3 index nodes, and to use memory optimized, and I defined 2 buckets here. The test I'm going to run is going to create an index using the CBQ image, and then do some data load with pillow fight and some queries here. And as the test is going, I'll come back through this in sort of real time and walk through what's happening and take a look at the Couchbase CLI. So looking at Sequoia, the framework, which is interfacing with Docker through the Golang API. And the nice thing is you can interface directly even with Swarm because it implements the same API. So we use provider Swarm again, and then I'm going to just start the test. So we're starting Couchbase containers pretty quickly here, and we're just going to wait for them to be available on port 8091. At this point, if I look at my Swarm cluster, what I expect, because from my scope I defined 3 index nodes, I would expect on the 3rd node, which is the index, to see 3 containers there, which we do. So the container is starting to build here pretty quickly. The cluster. So let's check it out, see what's happening here. Okay, so we're adding nodes. We had a timeout happen on adding one of the nodes. Okay, that's not too bad. So we're going to there. So you see, we added the index nodes, the query nodes. Again, this is creating the scope for doing the test and creating. Let's see. So. 3 index nodes, 2 query nodes, and then we'll start to get into actually running the test. So first thing, if you notice, we started to get IP addresses here that were plugged in directly from the scope. So this originally was defined as use a query node port, so use a query node and REST API, REST username, password. But by the time we got here to run the test, became IP addresses. Same thing you can see for the data loading. Because I set scale to equal to 5, you could see that we're doing things like, scale was 3. So we have a concurrency of 3 happening on the data loading. And that is happening right now in the cluster. So we have 2 buckets that we're loading data against. And again, these are Couchbase containers that are running, and they're running tests against workload isolated Couchbase containers, right? and what you start to see is similar sort of CPU usage across the index nodes, and the data nodes are fairly moderate, and the query nodes are about the exact same too. But we don't see this thing where if any of the services were spiking that it would affect the other one. And also, just another thing that's pretty nice, what we've done is essentially built logic around ways to use Docker containers for testing purposes, right? So when you see things like for each, that means we could say for each node in the cluster, or for each query node, do this select statement. And also do a range across this offset variable. So the way that comes across when we're running the test is you can see things like we have two different query nodes, so you see two different IP addresses being generated here. And then also this offset range is being modified too. So you can dynamically send queries and stress to the Couchbase server like that. And everything here that you're seeing is coming out from, this is actually open source. This container, Vegeta, was something that I pulled directly from Docker Hub. And I saw that it could be used to do HTTP REST stress. So that just shows how you can use something that's public and then plug it in and get scope variables. The test also was able to do weights for 2 million items and then start a rebalance. So we've already actually passed that 2 million mark. And so you could see what's happening. The rebalance already kicked in at that point. And again, the way that we can do this with containers is we can look at the logs from doing things like, well, what are the stats that are coming from checking, like we could check the stats from a container and then read the log to see what it output and then check against that for doing these sort of like weight things that you would want to do in tests. And again, I just said, hey, rebalance out the first data node. And this is actually a template. So one of the things that happens is, for instance, in you can see here in the rebalance out, it's essentially making a template of a common thing that we do in testing of doing Couchbase CLI, rebalance out, pass in a parameter. So we were able to take these images and build a lot of pretty neat constructs on top of it. And the only thing that's going to happen as soon as this rebalance finishes is it's going to do a CB collect info. And the other thing you'll notice is that the index nodes are completely unaffected. Query nodes are unaffected by the rebalance that's happening on the cluster. And just to double check here, the last node in our Swarm cluster was a client. So we should see some data loading and a lot of things happening on this one. So what you might want to do in this situation is have more client nodes. These actually are services that finish, but the ones that are still running are at the top, so pillow fight, things like that. And that is a basic example of how we can use Swarm, and you can start to see the, promise you, when I had another node in this cluster, the rebalance went really quickly. Removing that one seems to have slowed things down because I have one less data node and I replaced that with the query node. So that's starting to kind of affect my distribution. If I were to run this again, I would just add another data node because at this point we have, 10 data nodes, and in the Swarm, we're looking at 4, so probably on one of them we have something going on where there's 3 running. But yeah, so that's pretty much the the demonstration of how we go from defining tests and using Swarm in order to scale them up. So, okay.
Okay. Any questions? Do you want to? Okay.
So, do you have any industry vertical examples where you have used this, like financials or healthcare?
Yeah, it's getting.
Very good talk, by the way. Excellent talk. I want to know, have you used it in a live example in an industry vertical, such as maybe financial services or maybe healthcare?
So for our uses, it's predominantly test automation, functional test, and system test, though I do think we have containers available, people using them in the field.
Hi, I think it's a very good talk, thank you. And I was wondering two questions actually. One, have you made it work with Kubernetes pet sets? Had a chance to play around with Kubernetes pet sets, which are the new concept for stateful database type containers. And the second thing is, I'm not sure if this would be counterintuitive in production because of the way schedulers orchestrate the containers. Do you actually want more server density, or you want to give your database maximum RAM compute storage? So, sorry if there are two questions, Jay.
Yeah. So the first question, I didn't catch the name of the Kubernetes something, but
Pet sets.
okay. Yeah. We haven't experimented with that yet. And the second question was, I think it was, are people using Kubernetes in production? Not that I know of, but there are blogs describing how to do that.
I've actually tried to run on this Kubernetes, put Couchbase, and not managed to make it work fully. But then it struck to me, I thought it would be counterintuitive to put it in a container when the whole point was to give your nodes maximum compute and memory resources. In production, I'm sorry. So if I'm assuming we've not experimented production yet, or?
No, we haven't yet done any kind of load, or just to see how much load, how many containers could run on a given server.
Have you guys done any?
We're going to do over here and then come back to you.
So kind of related to his question about putting Couchbase on top of Kubernetes. Have you guys played with any of the persistent volume stores like Taurus or anything like that, and looked at the overhead of doing distributed persistent volumes?
I am familiar with them and how they work, but have not done anything hands-on with those yet.
Oh, we have one more. Sorry.
Not a question, one comment, but the question that was being asked. So in production, Amadeus is using it in production with Red Hat and Kubernetes. They can talk to them in more detail. But we are not using it ourselves in production though. But there are customers who are already using it. So Amadeus is a great example of that. And they have a partnership with both Red Hat and us, so that they can, if anybody has more questions, we can give them more insights into that.
Okay.
Yeah, so just real quick, my question was around performance. So running in a Dockerized build out versus running it on like a virtualization infrastructure. Do you guys see a performance difference between the two, or have you guys done any testing around that?
Not a whole lot of testing, but just anecdotally, we're seeing better results with containers than VMs.
Okay, thanks.
I guess I would say too, in system testing, like that example there, if you were to run that just flat against EC2 instances, it'll probably run better just because, you're running against the exact VMs. But the idea of there's certain optimizations where you can do things like CPU pinning. You can also do you can set like different memory quotas, things like that, to really get close to partitioning the physical resources on the machine. So what ends up happening is maybe you have a machine, you have to cut it down to smaller pieces in order to run just more instances. But if you, at the end of the day, for us with testing, if we wanted to say we want to run, the reason for like our scaling with Swarm is to say we want to run 50 containers and we have 10 VMs, right? So we kind of get ourselves in the box where like, well, how can we sort of optimize what we already have to get more instances and do it like that. So I'm not going to say that if you were to run 5 containers on one physical machine, that it's going to run, you know, just as fast as 5 physical machines solo.
If anybody has any questions on the performance testing and Docker, I can take it offline.
Yeah. Okay. Hey, thank you, everyone.
Thanks, guys.